In the last section of 2.2, evaluating limits algebraically, we're going to look at evaluating limits using the squeeze or sandwich theorem. There's a nice introductory video on Khan Academy, so if you Google that, Khan Academy squeeze theorem, you can watch the video, but basically in a nutshell, this is what it says. If we have two functions, let's say we have graph f of x that goes like this, and we have another function, say g of x, that goes like this, and let's say that they are, this value here is c, okay, and we can evaluate the limit as x approaches c of f of x and the limit as x approaches c of g of x, and let's say that we have h that falls in between these two. That would be h of x. So if h of x is between f of x and g of x, and if I can find the limit as x approaches f and the limit as x approaches g, and those two limits are the same, and if h of x squeezes between those two functions, then at c, the limit of h of x would have to equal the limit of c at both f and g. So that's basically what the squeeze theorem is saying. So let's take a look at an example here. So in this example, it says use the squeeze theorem to find the following limit. So if 3x is less than or equal to my function, which is less than or equal to x cubed plus 2 for 0 to 2, evaluate the limit as x approaches 1. So our function f of x goes somewhere in between these two. Okay, so here's how we would set up this limit. Okay, so we would say that 3x, is less than or equal to my function f of x, which is less than or equal to my function x plus 2. So now we're going to find the limit as x approaches 1 of all three of these. And that would have to be less than the limit as x approaches 1 of x cubed plus 2. Well, doing this first limit, if I plug a 3 in, this is going to be 3 is less than or equal to the limit as x approaches 1 of f of x, which is going to be less than, if I plug a 1 in, 1 cubed plus 2 is also going to be 3. Okay, so now we can see that the left-hand side is 3, and that is less than or equal to the limit as x approaches 1 of f of x, which is also less than or equal to 3. So therefore, by deductive reasoning and using the squeeze theorem, we can conclude that the limit as x approaches 1 of the function f of x is also going to be equal to 3. So therefore, by squeeze theorem, the limit as x approaches 1 of function f of x is also going to be equal to 3. So that is a simple example of how the squeeze theorem works. Okay, so I want you to pause the video, and I would like you to give this one a try. Okay, well, hopefully you've had a chance to try this one. So now let's take a look at how we'd set this one up. And this one's going to be very similar to what we just did on the last example. So I have 4. So I want to basically find the limit of all of 3 of these things in the equality as x approaches 1. So it's going to be the limit as x approaches 1 of 4 has to be less than or equal to the limit as x approaches 1 of f of x, less than or equal to the limit as x approaches 1 of x squared plus 6x minus 3. Well, the limit of a constant is a constant. It's going to be less than or equal to the limit as x approaches 1 of f of x. Again, plugging in, I get 1 plus 6 minus 3. This is also going to be 4. Therefore, by the squeeze theorem, the limit as x approaches 1 of function f of x is also going to equal 4. Okay, in this next example, they're asking us, or telling us the function f of x is cos 1 over x times sine x cubed minus 1 over x4, and it's bounded above by the equation g of x and bounded below sorry, bounded below by the function g of x, is bounded above by the function h of x on the interval -1 to 1. Is there enough information to determine the limit of the product of cos 1 over x by sine x cubed minus 1 over x to the fourth equals 0? So basically we have g of x is less than or equal to f of x is less than or equal to h of x. Well, g of x is the function negative root 1.11 minus x squared. But I'm not going to rewrite the trig one. I'm just going to write it as f of x. And this has to be less than or equal to the square root of 1.11 minus x squared. So now I'm going to try the limit as x approaches 0 of the negative of 1.11 minus x squared is less than or equal to f of x. Oh, sorry, I should put the limit in there as well. So this is less than or equal to the limit as x approaches 0 of f of x, which will be less than or equal to the limit as x approaches 0 of 1.11 minus x squared. While plugging a 0 into this left limit, I'm going to end up with negative root 1.11 is less than or equal to the limit as x approaches 0 of f of x, which is going to be less than or equal to the root of 1.11. Now we'll see that these two values are not the same on either side, so these two are not approaching the same value. So I would say that there's not enough information to determine what the limit as x approaches 0 of f of x is. Okay, in our last example, we're given the limit as x approaches 0 of x to the fourth times sine 3 over x. Now, we're not told what the boundaries are, so we have to start with something that we know. But we know that sine will always oscillate between 1 and -1. So sine of any function has to fall between -1 and +1. So we know, we'll start with what we know. So we know then that -1 is less than or equal to the sine of 3 over x is less than or equal to +1. So it really doesn't matter what function's inside the sine function, it's going to oscillate between -1 and 1. Now, to get the expression that I want, I'm going to multiply everything by x squared. So now I'm left with negative x squared is less than or equal to x squared times sine of 3 over x less than or equal to x squared. Now we're going to take the limit as x approaches 0 of negative x squared is less than or equal to the limit as x approaches 0 of x squared sine 3 over x less than or equal to the limit as x approaches 0 of positive x squared. Plugging in 0, I get 0 is less than or equal to limit as x approaches 0 of x squared times sine over 3x is less than or equal to, again, plugging 0 into this right limit will also be 0. So therefore, we can conclude by the squeeze theorem that the limit as x approaches 0 of x squared sine 3 over x will also equal 0. Okay, that concludes the section on the squeeze theorem, and that concludes evaluating limits algebraically. So please try the 6 questions on the handout, and we will cover those tomorrow in class. Oh, I know, it's not hard.
It's hard to keep up. Like, you can't just keep pounding them because they don't get anything.